Hello friends. Today we are discussing the system architecture and the memory management part 4, in which in the previous lecture we see about the segment registers. The segment registers are shown here of the the format of the segment registers are shown here, which consists of the CS, SS, stack segment, code segment, data segment. Okay, a 16-bit visible selectors are there and a hidden descriptors are there. For each task we use the memory segmentation. Okay, how we use the more memory segmentation for each task. A module A code which access a code, a stack which access the stack segment, a data structure where access the FS, data structure 3 access a GS, and a data structure 1 access a extra segment, and a module A of the data which access a data segment. For each of the tasks we use the memory segmentation like this. Also a page translation, how the paging will be done. In the page translation, a linear address is given to the paging unit which convert this linear address into the physical unit. Two-level paging session, how a two-level paging will be carried out. Here the control registers are there, CR0, CR1, CR2, CR3, which are connected with directories, and a page table is there. A user memory, from the user memory it connects to the linear addresses are given as an input to the directories. So with this it will goes to the page table, and page table will convert it into the physical memory. A page descriptor base register CR2 is used to store the 32-bit linear address of a page default, and CR3, that is a page directory physical base address register, stores the physical starting address of a page address. CR2, which is used to store the 32-bit linear address of a page fault. A CR3, which is used to store the physical starting address of a page directory. As shown in the figure, a page fault linear address register CR2 and a CR3. These two control registers are shown, and the bit pattern is also shown. A note 0 indicates that reserved or not defined. Page descriptor base register. A lower I2 bits of the CR2 are always 0 to ensure that the page directory is always page aligned. The move operation of the CR3 automatically loads the page table into cache and a task switch through the TSS register that changes the value of the CR0 control register 0. The page descriptors are having a lower I2 bits of the CR3 always 0, the page directory always a page aligned. A move operation CR2 automatically leads the page table entries caches and task switch through the TSS change value of the CR0 register. The page directory is the almost a 4 KB in a size and allows up to the 1024 entries are allowed. The upper 10 bit of the linear address are used as an index to corresponding the page directory entries. The page directory entry points to the page levels. It is almost the page directory which is almost of the 4 kilobytes in a size and allows up to the it has a maximum 1024 entries. The upper 10 bit of the linear addresses are used as an index to corresponding the page directory, and the page directory entry points to the page. This is how the page directory shows a page table address and upper user Each table is of the 4 KB and holds up to the 1024 pages. That is a page table entries. These are the page table contains the page table entries, which are the maximum of the 1024 page entries are there. PT contains, that is a page table entries, contains the starting address of the page frame and the statistical information about the page. What is the statistical information? What is the location? What is the memory address? All these things are the statistical information of the pages. Upper 20 to 20 bit page frame address is concatenated with a lower I2 bits of the linear address to form a physical addresses. The page table can be shared between the task and a sweep to the disk. Each page table is the 4 KB and holds up to the 1024 page table entries. PTE, that is a page table entries, contains the starting address of the page frame and statistical information about the page. Upper 20-bit physical upper 20-bit page frame address is concatenated with the lower I2 bits of the linear address to form a physical address. Page table can be shared between the task and a sweep to the task. A page table entry, as shown in the figure, the page table entries, a P bit, that is a present bit, indicates if the entry can be used in an address translation. A P bit of the currently executed page is always high. The present bit, P stands for the present bit, which is at the bit location 0. This present bit indicates if the entry in the page table entry is used to address the translation. A P bit of the currently executed pages is always high. A is A bit, which is at the bit location 5. Uh, A bit, it is set before any access to the page. If we want to access to the pages, we have to set a access bit, which is at the location bit number 5. How the linear addresses are converted? Example, the linear address is this one, which is now converted to the directory table and offset. The binary is this one, so hexadecimal conversion is this one. So a directory address is 00, c, a table address is 00, and offset is 08a. So a linear address which is given has to be converted into the binary, and then the binary is converted to the hex to show a directory table offset. So how the memory paging is done? So as in this figure, we see a directory table at the offset. How this is calculated? If the linear address is 0301008A, that is get converted into the binary, and from binary it will get converted into the hex. Accordingly, the offset is of the 12-bit, table is of the 10-bit, and a directory is of the 10 bits. So the bits are get converted, and accordingly the bits are stored in a directory table. So if the address is this one, how it will goes? First of all, the 00 directory address, okay, which goes to the location number some OX0501, and which is added with a table address of which is of the 10 bit, which is given, and then this gives to the location at the 0x0030, which is equals to 0x040. So again this get converted to and look finally stored in this location. So the D directory bit is a offset bit. It is a set before the write operation to the page is carried out. The D bit is undefined for the PDEs. OS is reserved bits. They are defined by the operating system software. US, that is a user or supervisor bit, and a read write bits. A read write bit, they are used to provide the protection. They may be like this. US is a user or a supervisor and read write. Permitted level is none or permitted access level for 0 read for the read and write. If a US and read write bit 0 and 1, then the permitted level is none and permitted access level is 0, 1 or that is a read and write. If a US and a read write bit is 1, 0, that is a read only. The permitted access level, that is a read write only. If both US and read write bits are 1, 1, that is the permitted level is read write and a permitted access is also the read write bit. Thank you friends for watching the video.